Alright, good morning. This lesson is for my Trig-Precalc class. Today is Wednesday, March 18th. I hope everyone is doing well. I would like to just discuss a couple realities of our situation. So I haven't graded the homework yet. The first assignment is due today. I would say let's err on the side of just completing assignments. The assignments I'd like us to be able to do. I'm sorry. I just lost my train of thought. I was distracted for some reason. Thanks, Stinks. So we need to be able to justify a passing grade in this class, and because of the situation we're in, I think that it's best if we just can justify that we were doing work while we were quarantined. So really, put the work on your side. Say, hey, look, I did all the assignments, I watched all the videos, and why don't you come say hi, Stinky, instead of just standing over there? I'm making a video lesson for my students. So yeah, the real important part about passing the class before my wife interrupted us. Let's make sure that we have the assignments turned in, so that at the end of all of this, I can say, hey, look, you guys did what I asked you to do, therefore you should pass. If you're not turning in the assignments, I can't make that argument for you. So let's make sure that we're doing everything we need to do. I said, again. The next thing, I received a question from one of you about problems number 9 and 12 from yesterday's assignment. Let me just go ahead and do number 9 real quick. Number 12 is going to really be very much this. Oh, no, it's actually a little different. So let's see here. So I wrote the rule that we're using. If logs with the same base are equal, then what the of numbers must then themselves be equal. So with this, the of numbers must then be equal. Remember, natural log is the same as log base e. So this is the same thing. My equation very quickly becomes this. I need to have this equal to 0 because I have a square, so I'm going to do some factoring. I'm going to subtract the 11r to the other side. I'm going to add the 3 to the other side. And in doing so, I'm going to be left with r squared minus 11r plus 30, and that's equal to 0. Now, I am going to be able to do the shortcut because my a value is 1, and so I can very quickly factor this. I just need to know my a times c. A is 1, c is 30, so a times c is 30. The only way to multiply it to a positive is if both are positive or both are negative. My b number is negative, so I need to use this. And the way that I'm going to multiply to a positive 30 and add to a negative 11 is I'm going to need to multiply by a negative 5 and a negative 6. So very quickly my factors become r minus 5 and r minus 6. And our answers actually very quickly become, let's say it again, r equals 5 and r equals 6. Plug in 5, I get 25 plus 27, so it's 52. That's a positive number, so a number can be raised to a positive number can be raised to a positive number through powers could be raised to a positive. So this is a good answer, as well as 6. 6 will make that positive, as well as over here. So that was how we did number 9. Number 12, I'm assuming the problem probably came with the factoring number. So let me start off with this one. It's we should hopefully got to this point on the problem. 4r squared is equal to negative r. And we're going to multiply, and we're going to say that. Oh, I made a big mistake here. Let me try to see. Well, actually, 4r squared minus, or plus 2r. Let's do this. Plus 2r. And that's equal to 80 plus 3r squared. Okay, so I need to get this equal to 0, so I'm going to subtract the 3r squared, and maybe this is where we might have got stuck. Because if I subtract the 3r squared, and I'm showing the step, you know, that cancels out. I'm going to be left with r squared, which is nice because I can again do my shortcut. I subtract the 80, so I get plus 2r minus the 80, and that's equal to 0. My a times c is going to be negative 80. And I'm going to be, I have to figure out how I multiply the negative 80, which means I'm multiplying by a positive and a negative. My larger number must be positive, and it has to be 2 larger than my negative. And fortunately, this is a very simple one to find, and it's going to be negative 8 and positive 10. Negative 8 and positive 10. And so we can, you know, finish the factoring. Hopefully this helps with this. I want to, if there's still questions on number 12, I'll go over it some more. Hopefully this was good enough to get us to the answer. Let's write our goals down for the day. And again, if I'm going too fast, you can hit pause. I'm trying to keep the videos relatively short. I know that I can ramble about mathematics for quite a long time, and for the sake of this situation, I want to keep it, you know, moving forward, but not overwhelming. So today we're going to be introduced to properties of logarithmic functions. All right, so our goals today are going to be to verify a logarithmic property, all right, and we're going to then use this log property. All right, so let me let's write down a couple ingredients here. I'm going to make the argument. I'm going to show you how to use it. It's a really simple lesson. So let's see here. So we can actually add this part to our cheat sheet. We're going to title this logarithmic property. And we're only going to talk about one of them. There's actually 3 that we're going to learn about. So the first one we're going to learn about is log base b of a times c. All right? And I'm going to be able to rewrite that as log base b of a plus log base b of c. So I'm going to show you that this in fact turns into this. And let's add a little bit more to this. If I turn this into this, this is called expanding. And if I turn this expression into this smaller form, going in this direction, this is called condensing. And you're going to be asked today to expand and condense. It's a real simple exercise. All right. So I'm going to introduce the ingredients to this. It's a pretty simple, I think, lesson. So I'd like to just talk about some ideas here real quick. First of all, we need to know something about exponents. We need an exponent rule. And the exponent rule that we need is going to be a to the power m times a to the power n. And what happens when I have the same base number is I can keep this as one base and then add the exponent. So I'm going to need this rule to make my argument. And then I'm also going to need our basic log, our definition of a log. And the definition of a log means that if I have log base b of a and that's equal to c, that can be rewritten exponentially as b to the power c must equal a. All right, so I want to make my argument here. I need these ingredients. I'm going to show you that these are in fact equal. So what I'm going to do is I'm actually going to start off with two separate logs. If I have, let's say for example, so here's my argument. Okay, I'm going to verify. I'm going to do the first goal. If I have log base b of a, and I know that I'm going to say that guy is equal to some letter, let's call it m. And if I have my log base b of c, I'm going to say that that's equal to an n. I'm going to rewrite this using my definition of logarithmic. So now I get b of m is equal to a, and I'm going to do that as well right here. B to the power n is equal to c. Alright, we're almost done with our argument here. So what I'm going to do is I'm going to multiply this left side of the equation by this left side of the equation, and I'm going to multiply this right side of the equation by this right side of the equation. We're multiplying both sides of this equation by the same number, they're just in different forms. So what I'm going to have here now is I'm going to have b to the power m times b to the power n, and that's going to be equal to a times c. I want to make sure I'm in the lines here. Okay, good. I'm still in the lines. All right, so now I'm going to use my exponent rule, which allows me to say that this is now b to the m plus n, and that's equal to a times c. All right, now I have this, so I'm going to rewrite it like this. And so now this is going to become log base b of a times c, and that's equal to the exponent, which is m plus n. Now we're almost done with the argument here. I can say the letter m, or I notice that I also have the letter m right here, which I can replace with this. So instead of m, I'm going to now say log base b of a. So log base b of a times c is going to be equal to log base b of a, because this is this, and I can replace it with that. The same thing is going to be true for n, so instead of saying n, I'm going to replace it with log base b of c. And in doing so, I just verified that property. So now we know that this is a good property. We know that this property works. And I want to make sure that everything is in the picture, and it is. All right. I'm going to try and wrap this up really quick. So, again, if you see something like this and you're asked to expand, you write it like this. If you see something like this and you're asked to condense, you write it like that. That's all I need you to do today. So again, I hope everyone's doing okay. Thoughts are with you guys. And again, let's make sure that we can say, hey, we did everything we needed to do in this time, and we do all the assignments, and let's make the most out of this experience and do our best. So again, I hope everyone's doing okay. I will post the next lesson tomorrow. Have a good day, everybody.